we move to the third program challenge for our chapter 2 to do some enhancement for what we have done for this projectile trajectory comparison. So in our existing code, we have already did is we have 3 lines or 3 the projectile trajectory, if we see that, and let's see what the challenge we want to get is the first. Our new program should print the time of flight, maximum horizontal distance, maximum vertical distance traveled for each of the velocity and angle of the projection combined. So before that is also will pop up. Our question is to ask you how many trajectory you want to draw. So those are the first the outputs, and another enhancement is to make the program work with any number of initial velocity and angle to projection value. So that means we need to put both initial velocity and the initial angle as the variable or the input by user. So these 2 parts is the major enhancement. And then the program should also ensure that error input is properly handled using try except. So we will try to reuse the over 2422, the comparing trajectory as much as possible. So let's starting from this. So let's change this to 5, and then this is our third challenge, enhanced. So let me put that here, enhanced, and we save that. And by the way, is again, so if you go to the GitHub, our source code is already uploaded and synchronized to the repository. The latest one is this visualized quadratic function. If you click that, you will get this source code. So I hope if you need read that challenge PDF provided by user from the book website I mentioned earlier. Or you can check this source code as the sample or reference from my repository. You can fork this repository or download that so that you can check the difference of the code. In my code is primarily I will have kind of the further improvements from the basic the code. For example, when we did this comparison trajectory before, we did already discuss this from the tradition 1 or standard 1 to make those the theta or u can be adjusted. So those we can use as our the initial parts. So let's see. So we will draw this. Let's see, so we put that is enhanced. Enhance this projectile trajectory. So, and with the date, let's see the what's the changed, what's the not changed. So we can put this import in the most the beginning of the program. So, and then this generate French is no change, I believe, and we will have our the draw. So this G is we can put that as the global the variable. So we can put that in the beginning. So then, and let's see the draw graph. So draw graph is plot xy, input xy, and with the xy coordinate as the label and title. So this title, we should make some the distinguish so of not 1. So with the different initial velocity and the angles. So those are our current. So let's just run. So in the last time is we make many. So we give a list, and then this based on the angle and the same speed or same the initial velocity. So we get these colorful things, but we will let those convert to the variable. So French is okay, and the draw is updated, and then let's is a number of days will start less than final. We put this number append to start, and then we have this incremental. It's just to help the adding those. So this interval is input is from the increments. So that is the same, and then we return this list of the numbers. Then let's see the draw trajectory. So this we will have some the difference because we want to draw multiple. So we will enhance this function first is the t flat. We are adding the another one. So we will first list down this list of the x and the y. So x and y first is the this empty, and the interval is French 0 and the t flight 0, 0. So this one is fine. And then our t flight is input is not like this directly. So that is we don't need to make this one because we don't have that calculation, and also theta we will read from we will put that conversion in the outside. So let's just have an interval and xy and make this for t in interval. We make x append. This function is still the same. The g is here because g now is the global, the constant. So it's that is okay. And then we draw this. So create this draw. Now let's adjust our this min program. So we will use this try. So we unhide this and delete that. So primarily is those one is fine, but now we will do the print. So first we need to ask people how many trajectory people want to do. So first is number of trajectories is we ask people to do our int. So int is input how many trajectories in integer. We will have a question mark. So first we need to read on this. Then once we have that is we will make our velocity. Velocities as our empty list, and also angles as our empty list. Then that's the depending on is what are the inputs. So we will also need to collect those inputs. So this will be our inputs, the collection, the looping boundary. So for I in range, E is 1, and go to this +1. So always consider the boundary is due to the this index starting from 0. Then is we put is V is input. It can be the floating, so that is fine. So we do this. Please enter the initial velocity for trajectory. So we need to let people know which one. So we will give this formatted the print. So 0 with meter per second, and then we give a comma and then dot format. And here we get I. So and similarly is we also have the theta input. So we convert the theta in this program. So that is the input. Please enter the initial. This not be the initial. It's just the angle of the projection for trajectory. Give a number, the 0. So if you only have one formatted print, actually this 0 can be ignored. But we put that. Here we collect just the degree, and we will convert that to the radians, the coordinates. And the same is we have space and dot format, and with I. So now we have these two, and then velocity. Velocities we will put that append to this convert that to float. Yeah, remember when you collect that is a string, and then the angles dot append is not only not the float is after float we do this mass. So that ensure is you keep this input mass, and the mass dot the radian, and with float you cannot keep that as this string. So even you treat that as a degree, but actually it's a string. And then this we can have those 4. So if we have those try, so we can put all of them is try. So let's make those here. Try, and this one I don't need that, and I will put that in indent. Then if there's any those arrows, I will catch that, and yeah, we will see so how we will draw this one. So first is I have those one input. I will print. So first do the print. So for I in range number. So I will try to print like this way. We already have the this line, and we input this line, and what we need to print out is calculate where we need to print out several parts is time of flight first, maximum x, maximum y, and angle for projection combination. So those are 4 parts. Is we have every trajectory the looping. Then let's do this. Let's see, except value arrow. So yeah, that. Because we have this 4 now is t flat is let's see is 2 times velocities times mass dot sine angle. And now is every variable we give this index. So angles divided by g. So just try to review the formula. And then the Sx is equal to velocity I times mass dot cosine. Cosine is angles I times t flat. Yeah, here ensure you don't have the typo, so that is the mass. And we see the y is equal to velocity I. And then this is mass is on the vertical part is mass dot sine angles I. And this will here times half y, so half t, so it's the t flight divided by 2, and then with minus 0.5 times g, then times t flight divided by 2, and with the squared 2. So let's just ensure you type in the correct formula. So you have both t flight sx and sy. So and the angle. So angle is we will have that already. So let's starting to do the print. So print is the first is the initial velocity, right? So let's use those kind of the format. Give our comma angle of projection. So this we don't need to calculate. And then dot. So this format is velocity I angle. Angle is we will put that change back to the degree again. So because now the angle is in the radian. So remember, so degree angles I. Let's see whether we have the correct parentheses. So here, this one is this one. So in the VS Code, they can have those the pair. So if you highlight this, they will show you this one. So if I highlight this one, it's the angle. So looks like these are okay, except let's list this different degrees. So those I don't need. So let's not call that first. So let's see whether it's running for the first one. So name this one, which line? So line 1. Def u theta. Which one we use this? Oh, I didn't. Oh, let me save that. Expect our indented block after else. Oh, okay. So let's not draw this. Just print. Okay. So I will skip this one. Oh, not saved. Okay, so how many trajectory? Let's just make one. So don't, and please enter the initial. So let's see the initial in our testing. 45 and 45. Let's go to this try. So 45 speed and 45 degree. So now it's print 45. Yeah, because I only have angle now. So they first is print the angle, and yeah, the mass. Oh, y is only print angle. You enter an invalid. So this one. So how this come to the invalid? So 45, 45. Where to print? Not go to here. I go to here. So float 45. Yeah, so that is the kind of the interesting. So first is mass days and angle days. Let's continue. So print. Yeah, let's use the single quotes. This also change to the single quotes here. Then this one is we will put that t. That is 1, and sx, that is second, and sy. So I put this x as small. That's the third. So we have those part then dot format, and this format is t flight sx sy, and then we will print another blank line, and then within 4 we will draw these parts, but this draw should draw the every part. So the velocity, so is here based on I, and theta is the angle, angles I, and also we give this t flight. T flight is in here is we also use this t flight. So this t flight is used. Let's see, is here to generate those list of time. And then is we will continue at the legend. So this one is we don't need. So we put that except. So for this we also have inputs, and then we have this one is not inputs anymore. So we will put in that here. 4, and then we will use this to continue the print. So the legend is equal to our empty, and we will for I in range. From 0 to numbers of trajectory. So we will create a legend dot append is with those numbers. I think it's 1. That is 1, and that is 2. So format, we will put this velocities 1. Velocities 1, and mass dot degree, angles 1, I. So this should be the I. And now we can we generate the legend. Then we can do the PLT, the legends, And before this, I think it's Legends, END. Oh, this is S. And here is we draw this trajectory with this one, and we already have the plot. So here we have this draw, and here we have the plot. And the last is we will do the show. So here is the S, and we will put plt.show. So now we can see whether we have any arrows. So let's just starting from first 45, 45. Oh, I got is you enter the invalid inputs. So still the invalid inputs. So try this. How many? I put this try. So number of these I need are the one that is an integer. That's fine. Velocity is one. For this in range, let's try to split those activities. So all the inputs I will put in here. So let's here I put this here, and I will not go to this V. Oh, so this must be V. So I should put in that here. And then try this except the arrow. So let's see what may have the arrow. So these are the format I. So I got this format and input this and enter that. And theta is input. Oh, input. I put is 2 inputs. Inputs, so is this one. Inputs this, and one more. So yeah, this I have a duplicate arrow. So let's starting from 1, 45, 45. And then these calculate mass sign. So these are the 16. So these are angle. So these are typo again. So now let's run. So starting from first. So now it for 65. Let's see mass degree angle. Mass degree. So this mass degree. So let's see what's the reason. Oh, so it's degrees. So that is the correct function. So let's see. So not here. So 1, 45, 45. Oh, perfect. So now we have our legend to show this one as well. So I gave this one. Let's starting to do the testing. So based on here 45, 45, 60, 45. So let's do test. So I have a 3 line. So first is 45, 45, 60, 45, and then 45, 90. What I will try. Okay, so the 90 is the interest is so if you make a 90, the degree is actually come to this directly top. So that's the angle. So it's as a line. So if I put this 45, I think this is correct. But I suppose is the author may not see these are 45. Is maybe the yeah. This link is not looks good. So 3, 45, 45, 60, 45, and let's switch this 90, 45, or maybe 40. So let's make that smaller. Okay, so now these are three the trajectories, and also with our legend. So if I now I can put 4. So let's see if I have a 4 with one from the another direction. So 45, 45, maybe 65, 45, 90, 35. And then this, let's see, I have another 70 is, I will give a degree. It's not the negative degree, but it's maybe I put is 120. So now I have 4. So this one is in this left direction, and every part is we have such kind of things. But here you see the angle. Angle is they calculate from this Excel, not from the Excel positive Excel. They also calculate from the negative Excel. So this is 109. The 20 actually they put that into the 70. Oh yeah, here is 120, but it's too long. So maybe it's we need to give the formats. So when I print this angle. So I think that is here. So we put our comma dot f 2f. I think it's like this. Let's do a test first. So not this. 2f. So I think it's not correct. Let's Control C. So let's put this and here. So 1 is the 60, 1 to 0. Oh, it's still. So I think it's that's the F2. Yeah, it's actually 2F, and now you can see here is a print 200, and whenever those, I think these velocity, let's ensure is all those are just same. So I don't want this to print too long. And also our legend. Legend is I will put all of them is like here. So now let's do the final test. So I just wanted to draw 1 is the 80 in the velocity and 1 to 0 in the degree. So now you can see here 80, 00, 120, 00. And we have this line. Actually, this line is coming to the left. So those one, I hope you get the enough things to practice. We adjust some parts, and also we add this try the else, so that we can also try the one more is to see one if I put is some the different the invalid those characters or numbers is catch by the value arrow. So that is the thing is you also need to keep using this try except. So I hope is you can do like this and refer to this and try yourself to make this enhanced the program working. So next one is we will visualize the expense, putting this some different category of the money the expenses. Then we draw those not a line chart, but we will try our another type of the those plotting chart. So see you in the next video. Bye for now.